session. Welcome everyone to the June 18th session of the AACG meetups. Today we are sharing work by Peter Houk. Peter is a renowned artist, a Renaissance man. He's admired and respected and beloved throughout the glass, the academic, and the creative worlds. He's with us today to share his dual loves of glass and light. During COVID, he also created a wonderful group of works of Murini and Kane, and they're in a virtual exhibit at the Duncan McClellan Gallery, and we'll put a chat to that catalog in the chat room. A few housekeeping things. Please stay muted. If you would like to ask a question or make a comment, put it in the chat button and we'll relay that to Peter. If you'd like to see Peter speaking primarily, choose the speaker view in the upper right-hand corner of your screen. I also want to introduce Debbie Tarsitano, who actually introduced me to Peter Houk a number of years ago. And Deb, would you like to say a little bit about Peter? Unmute yourself and just give a little bit further introduction for us.
Hi, everybody. I just want to say how pleased I am to have known Peter for these many years. And I've watched his work change over the years. Peter is a multi-talented person and also a very nice person. And the thing I could say about him, if I could say one thing about him, is that he changes perceptions. His work changes the way people think about glass and art. And so I'm so lucky to know him and our friends at MIT. It's a great place, but Peter is a fantastic artist, and I feel he's one of the most innovative amongst us.
Thanks, Debbie. With that, Peter, share your screen, and we're excited to have you with us today.
Thanks. Let's see. I think I just unmuted myself. Did I?
Did. Yeah.
Okay, good. Good. Okay. So, well, before I eliminate my image and share the screen, I just want to thank both Mary and Debbie for asking me to do this and giving me the chance to talk about whatever I felt like talking about, which has been a really nice gift. And thank you for those kind words, Debbie, by the way. It's been about a year since I gave a slide talk of any kind, really, about my own work anyway, given a lot of stuff having to do with MIT and the Glass Lab, but this allowed me to kind of step back for a bit and think about what I'd be interested in talking about. And so this is kind of an unconventional talk that I want to give that's going to bounce around chronologically a little bit, but it's really about kind of a developing awareness of light and the dynamics of light and the way that transient light effects can affect emotional states with the help of glass. So that's kind of where I'm headed with this. So I will, let's see, share my screen. Okay, can you see that?
Yes.
Okay.
We see the whole presentation in the sidebar as well.
Okay, so one problem I'm having is that this bar, the zoom bar at the top, is keeping me from starting the slideshow. There we go.
Yep.
Okay. All right, good. That looks like the first slide. Can everybody see that okay?
Yep.
Okay, good. So yeah, like I said, this is really a talk about light and glass and how my feelings about and sense of glass and light has changed over about 30 years of working in glass. So I started out not in glass. I started out later than a lot of people start in glass as a painter and a printmaker, which was what I did in grad school for training. And And when I went back and looked through my painting and printmaking slides, which I don't do very often, it occurred to me that the ones that I liked the most, that really spoke to me, were the ones where I had tried to use a sense of light, a dramatic sense of light in the image as a way of conveying a certain kind of emotion. And that's ended up being true in glass, although I didn't really think about it. It didn't occur to me for a very, very long time that that's kind of what was going on. So I just wanted to show a couple of really, these are more than 30 years old. They're probably closer to 40 or 35 years old, things that I did during and after grad school. Just two things. I'm showing you this painting and then an etching done on a glass plate not that long after I started working in glass. So I've just always been interested in these kind of low light situations that can convey a certain kind of emotional state. So when I first started working in glass, I think these are from 1991, I was completely dragging all the kind of painting concerns that I had in glass and the printmaking ways of thinking into glass. So I worked in flat glass at first, and I didn't know any glass blowers and didn't know there was this whole sort of world of people working in glass until I met Susie Shapiro and Andy Magdans, and they ordered me out to Pilchuck in about 1989 or 1990. And then I realized, oh, there's this whole community of people. There's this whole world of people working in glass. But no, I just knew some people with kilns and somebody who knew something about enameling and somebody who turned me on to hand-blown glass that had a flashing of color on it. So I was just playing around on my own for a while and thinking a lot about glass as just sort of a transparent painting surface in a way, so that I was thinking in additive and subtractive terms. So this one on the left is a window. These are both windows for a recording studio that used to exist downtown in Boston and closed up a few years ago before the pandemic. And so the one on the left it's window glass. It's just window glass. It's been sandblasted and enameled very lightly with some vitreous enamel, some of the Rouchet enamels, and then fired. And then the one on the right is a subtractive way of thinking. It's all about removing blue until they're, until you're done. So this is just to illustrate that, I'm really thinking about glass at the start the way that a painter and a printmaker thinks about glass. And this was a larger window done around the same time. Same kind of idea, only a combination of additive and subtractive ways of thinking about just the surface of the glass. So, for the first few years I was working in glass, I was really just thinking about, why am I getting an echo? Anybody? No?
Could everyone make sure that you're muted? Sometimes there's a reverb if somebody's.
Yeah, I think it's a muting issue probably. I think it just went away. Good, thanks. That helps a lot. So yeah, for the first few years working in glass, I just thought about the surface as a thing that could transmit light, but just the surface of the glass as the thing to be working on. So, this started out as a piece of just clear float glass that got enameled all over with enamels and then sandblasted. So it's a combination of additive and subtractive approaches, but still really like the way that a painter would deal with the kind of the surface of the glass. Not the way a glass blower thinks about the way that light moves through a piece and in 3 dimensions. So this is like about 1996 or 1997, I got a really big commission to do a row of windows, a big wall of windows at the Seaport Hotel downtown in Boston, which was the first major skyscraper hotel in the Seaport area when it got discovered and renovated from just a giant field of parking lots into a new district. And so the idea was to come up with a composition of some kind that would serve to be this like division wall between a hallway and a swimming pool. And I had this drawing of a bunch of schools of fish and showed it to the folks at the hotel, and they liked it. And So I did this thing that's enameled glass. It's about maybe 20 pieces or 25 pieces, 4x4 and 6x4. So they're big pieces, and they had to get enameled and then tempered. And we fired the enamel at the same challenging, from a technical point of view, it was a challenging thing. And it came out, looking a lot like the drawing, and I was more or less pleased with it. And then soon after the installation, when I came back to take pictures of it, I saw this kind of thing going on, and I really, really wish, I was telling Mary yesterday, I wish I had video of this, because what happened is that the sunlight comes into the pool space, hits the water, which is moving because water's moving, and the light comes projecting through, and the shadows come projecting through the imagery on the glass, and then projecting that onto the wall. Someday I'm going to go down there and get some really good video of this, because it's like you're watching a little movie of fish swimming around, and it was better than the piece. I looked at that and thought, this is much better than the enameled part of the piece. And then it occurred to me that actually what's interesting is making glass where you can make both things happen, where you can have a kind of a nocturnal life and a diurnal life, where the glass can be kind of go to sleep a little bit, or have one kind of character, and then when light becomes a dynamic part of the piece, it can wake up and do something else. And I just had never thought about glass that way. That's not the way that painters think particularly, and so that kind of early realization made me start looking for these opportunities in the architectural things that I did. And a lot of the work that I've done over the last 2 or 3 decades has been architectural commission work, flat glass in houses and environments. But I'm also kind of a closet glass blower. I'm one of these glass blowers that just really likes to blow glass and loves the process. So you'll see more of that later. But so then this was a commission for a room in Cambridge, a bathroom in a house that got all renovated. And we noticed that there was a direct exposure to the light and a giant tree outside, which was really beautiful and cast shadows on this thing. And we decided to go with a kind of a theme, a motif of dots I was thinking about the way that when light shines through trees, especially during an eclipse, you can see all these little circles all over the ground. And I wanted to try to recreate that in the bathroom if I could. This is a close-up of what these windows look like in this room. And it did have the effect of projecting when the sun is at a certain angle for 2 or 3 hours during the day. It would send light through, and then you could see these dots just kind of slowly moving across the bathroom, across all the surfaces in the bathroom, across the tub and the floor. The floor, we also decided we would make, we worked with the architect to get these dot tiles, and went very circle crazy in this room. So that's sort of an example of post, after the revelation that you can really harness light. This is another kind of a strange one, a countertop that I did for some people up on the Cape, or actually up in the North Shore in Boston. And we broke the first one, unfortunately, because the table underneath it had not been built securely enough, so it cracked right in half. So we had an opportunity to do it again, which was kind of a good thing, because I thought about it and realized we could do something better. This is actually a countertop that people work on in a kitchen. So they knew they were going to scratch it, and that was okay with them. So it was okay with them, it was okay with me. But what we are looking at here is 2 layers of glass, a layer of, a layer of 3/4 inch glass that's been sandblasted on the bottom, and then a mirror facing up that's been sandblasted a lot, so that light can bounce through the mirror but back up through the glass. And knowing where the depth is in this is kind of difficult, which I like a lot. So this one doesn't change that much during the day, sort of, but it doesn't have a lot of direct light, but it's a very subtle kind of thing. Then this was an interesting one with in a California commission where the only light source in the room were 4 windows, these perforations in the outside wall that did get direct sunlight. So you had this opportunity to kind of play with color smearing down these very deep openings in the wall. And so this one was kind of easy because you get to be the only light source in the room and you're facing south, and wow. I think what I decided here though was that I didn't want anyone to be able to look in or out. I wanted it to be a very, they call it the meditation room, so I really wanted it to be a hermit-like space. And then this is a commission I did about maybe 10 years ago that combines not blown, but hot worked, sculpted, colored glass that gets cut in half and polished and then glued to both sides of a piece of float glass. This was done for a place down on the Cape. Actually, a biology professor, kind of a funny story. I won't tell the whole story, but I had pitched this piece to MIT, and the funder didn't really like the piece, but one of the people in the meeting really liked it. And after the meeting came up and said, I would like that in my house. So it got to happen anyway. So anyway, that's what that looks like. That's the whole piece is maybe 6 feet by 4 feet or so, and held to the wall with these very heavy standoffs. So when the light comes moving by the window, these things are shaped kind of like lenses so that they will smear light around the wall. And then you get a kind of a color mixing thing going on because these things are glued on both sides. And so these things move across during the day. You get this sort of slow dance of color and light, of refraction, of shadow moving across the wall. And then at night, what the piece looks like. So it's much more static, but it's dramatic in its own sort of different way because they did put a bunch of overhead lights above it so that it could do things at night too. But it goes from kind of being a moving kinetic piece during the day with the sun participating to a more stable thing at night, I guess I'd say. So I did want to mention that I did get into glass blowing about 25, 30 years ago when I went to MIT for the first time. Paige Hazelgrove asked me to come. Paige was the director of the MIT Glass Lab until 1997. And she died very suddenly, and then I was asked to take over the program. And in that short period where we overlapped, she taught me some glass blowing, and I went out to Pilchuck and discovered that maybe I was interested in glass blowing after all. Because I just didn't like the whole glass blowing scene very much at first. It just didn't seem to apply to me. And then, once you try it, if you like it, it's pretty hard to stop. So the main thing I learned from Paige at MIT was that if you blow your own glass, you can generate your own ideas, that blowing glass sort of perpetuates generating new ideas. And that had not occurred to me. And the other thing she taught me about glass blowing is that you don't have to be the best glass blower in the world to blow glass. You just have to be good enough to make your own stuff and generate your own ideas and then make your own ideas. And that seemed liberating to me. So I wanted to show this because this sort of goes back to some of the flat glass that I was doing at first. These pieces were kind of all about the surface, working the surface of the glass and sandblasting away color, using transparent and opaque colors to kind of deal with the surface of the glass a lot and patterning, and not really thinking so much about what happens when light gets to be part of the piece. But as I started working more, with this idea of the dynamics of light, that started to change a little bit. So this is an earlier kind of more opaque, I'd say more like a painting, more like a print in a certain way. And then I started to use more transparent colors so that the light can move through and project onto things. So that, so a vessel is not just an object with a design, with a decoration on it. It gets to become kind of a light device if it's in the right kind of conditions. I mean, it also sort of depends on the custodian of this piece to put it in a place where it will activate, like this. I started paying attention to things like the opening. How big is the opening, and what is the wall shape of the piece like? So is there an opportunity for light to come through the mouth and project through and make this other little landscape that ends up being part of the piece? So yeah, this is a close-up of another one, and that's just like looking through the mouth of the piece. Well, it's actually the sun itself projecting through the mouth of the piece onto the side wall. So I like it when that happens. And then there's a couple of light boxes here that they're boxes with blown pieces that got slumped back flat again, then sandblasted and painted, sometimes on both sides. This is me sort of going back to painting to see if I can squeeze some more juice out of that lemon, and they kind of work. They don't change the way that some of the other pieces change. I mean, you can turn them on or you can turn them off, and that's kind of all there is to it. That's another one of those. And these, just for sense of scale, these are about 22 or 23 inches across and 10 or 11, 12 inches high, pretty much as big as I could blow something and then slump it out flat. So I'm going to really shift gears here and talk about MIT a little bit, but this is part of my light talk because this project light became a really important, in fact, a central part of the three-dimensional printing process. This is a picture of Mike Stern, the student who was in the glass lab with me for a bunch of years blowing glass and also majoring in mechanical engineering and specifically in three-dimensional printing. And one day he came to me and said, "Hey, what do you think of the idea of building a 3D glass printer, a fused deposition modeling stuff that would squirt hot glass, like a toothpaste tube out of a kiln and make a 3D print?" And my first response was, "I think you're crazy." And the second was like, well, it should be possible because the materials to do this exist and the technology exists. It's just more a question of, will the material behave? And so we started out the way that scientists start out, just with the most simple tests that you can imagine. So we got one of these vitrograph kilns and put a hole in the bottom of it and watched the glass drip out. And this happened at first, which was not particularly encouraging at first. But then we started to generate these little autocoiled tower shapes, which was kind of encouraging because it makes you understand that glass would like to stick to itself and build on itself, and that's a start. And we were able to print them, and we had to torch them and everything because they would lose heat and they would get cold, and then we'd yank them out and they'd crack, and it was all just really chaotic for a while. But we were learning things, and then kind of moved on, still just dripping out of a hole, to pushing the print bed around by hand. We call this bumper printing. So we could just see, could we build a print? Can we actually move a print bed below dripping column of glass and make a print happen? And so that sort of works, but you can see what happens is there's a lot of instability. So if the glass begins to wiggle a little bit, as it does on these bottom layers here, then it just propagates that error all the way up throughout the piece. So what's encouraging here is if you look at the edge on the side here, you can see that that's a pretty regular looking layer. Like the layer thickness remains the same, even though the shape is pretty chaotic. And that's a good thing, because that means that the glass is wanting to cooperate, if you can just get it to. So we designed this printer that would have a crucible on top. Can you see my cursor? Anyway, there's a crucible. This box on top is a crucible. And then the box on the bottom is an octagonal kiln where the print would get printed. And then the nice thing about that is that everything is heated. So the top is at 2000 degrees to melt the glass, and the bottom is at annealing temperatures are about 1000 degrees. So the glass freezes as soon as it gets down into that annealing zone, the glass will freeze. So we went and built the printer, and that's what it looked like. Pretty primitive looking, but it was hooked up to a controller, and you could generate code. And then the print bed would follow using a series of servo motors, would be able to move the print bed in the X, Y, and Z axis to hopefully make a print. So the real turning point was when we were able to put a nozzle in here. This is the nozzle up here, and print very, very close to the surface of the nozzle. So this dimension is about 1/4 inch. That is the thickness of the print layer is about 1/4 inch. And once we started doing that, we realized, okay, we can make some shapes happen here. So this was a first attempt at the design space that might be achievable with this printing technology that we were inventing. So we took things like the minimum turning radius of the machine and the minimum and maximum draft angles. In other words, the angles that you could print before the print wants to collapse in on itself or out away from itself. And we started a little zoo of shapes here. So the one that's circled here, I think we called this the twisted egg, got printed. So this was one of the first prints that we actually made with the machine using code, and it produced a shape that actually looked like the drawing with very little error now. So we proved that you can actually print, but then we were kind of like, well, okay, we can print these shapes, but what are they good for? And what they became good for was doing things with light. So, and this was unexpected. We were just playing with them, and then night came and somebody put their phone inside one of these things, and that happened. And we realized, oh, we've been printing lenses here. This is a circular spiral extrusion that's essentially one long lens. So depending on the curvature of the shape, you can design for any number of ways of making these light caustics, or the concentrated reflections of glass happen. So here are 4 prints from that very first series that we did in the glass lab. And then we had a show in the media lab of these over in the media lab just across campus from the glass lab. So you can really see how the shape relates to the set of caustics generated by each one of these things. And that was kind of our first, we called it version 1 of the printer, what the first show looked like, a set of objects. So then we, at that point, when we're in the media lab, Neri Oxman, who was at that time leading a group in the media lab, decided to unleash some resources on this. So she very kindly offered a couple of students an opportunity to get master's degrees to work on a thesis on this, and found us a bunch of funding, and we got a really good project in Milan, Italy, at Milan Design Week to build something there. And they gave us an incredible room at the Triennale Museum that's about 150 feet long and 50 feet wide and about 30 feet tall. So we decided, let's build some towers. So these designs were done by Chikara Inumura, who is no longer part of MIT. He's moved on to a design practice on the West Coast, but Chikara was very aware of Antoni Gaudí and Gaudí's work and loved the idea of transformation of shapes. So in plan, we thought we would make these shapes that morph from 6 lobe at the bottom to 3 lobe at the top, 4 at the top, 8 at the bottom, 10 at the bottom, 5 at the top. And if that's confusing, maybe this will help. This is what the columns were to look like. So each one is made out of 15 pieces of stacked 3D printed glass. They're compressed by using a load cell and a compression rod that was threaded so that we could really put some compression on them so that if somebody touched them, they wouldn't fall down. And so we had to build a bigger printer, a much bigger printer. So we built this printer with the help of Fred Metz, who built the lower part, and a bunch of some people at Nikon gave us some engineers to work with, and a bunch of different people helped engineer and build this thing. And away we went. We started building parts for the columns that we needed to show in Milan. So these are two of the parts. This is the 5 and 10. 1, 2, 3, 4. Yeah. So the bottom piece would have been the one on the right here, which has more glass and it weighs more. So we put it on the bottom. And then that's the 10 lobe, and then the 5 lobe would have been at the very top. So when light shines through these things, they look like this. And you'll see, I'm going to show you some video. We decided that we needed to make the light move vertically up and down so that it became an even more dynamic feature of the internal space. So we shipped everything over to Italy, got some staging, and arrived about a couple of weeks before design week and put these things together and made sure the electronics worked and everything. And then it opened, and there was this big space that people could come into, and there was a lot of this kind of thing that went on, people sitting around the campfire looking at the light. And one of the great things about this is that we managed to encourage the museum to allow us to not use any emergency lighting in the room. So the only light sources in the room were these 3 columns. They had to put extra guards in here because of that, because they were afraid that something bad might happen. So that there were a lot of guards in the room also, but not everybody in there is a guard. So I'm going to show this. Oh, yes, you didn't see these yesterday, Mary. These were a couple of other experiments we did with a 3D printer in the second version. We found that we could print separate cavities joined together. This is all one big long print that are watertight and can hold fluids. And this has some potential for architectural uses in buildings that may want to have fluids as actually part of the building skin. And then some crazy prints like this is one that happened kind of accidentally when we crashed the nozzle and continued to print. And it's one of my favorite things that we ever made, but I don't think we could ever do that one again. So I will show this video next so you guys can see what those pieces look like when they were actually the towers, what the towers look like when they were in action. Oh, I'm going to pause for a second. What you see here is a load testing, failure testing of one of the components. So before we could do this, we had to know that these weren't going to just like fall down and crash and hurt themselves and hurt other people. So we did some failure testing with a real lab on these. And I don't know if you're going to be able to see it, but this piece before it got smashed in the Instron was getting 300,000 pounds per square inch of pressure, and then it finally blew. All right. Can you
Thank
hear me again?
Peter, we have one question. How many extra pieces of glass did you have to take to Italy in case of breakage?
Oh, that's a good question. We shipped an entire spare column, so 15 extra pieces. But that's sort of deceptive in a way, because if just one piece had broken in any one column, we would have had to use all 15 pieces of that replacement column. And if two pieces had broken in separate columns, we would have been out of luck. But that didn't happen. I mean, the Pelican cases that we used, that was another of Mike's ideas, was to use Pelican cases for these, and it was just brilliant. We didn't have any breakage at all. And we were very careful and drank a lot of coffee and stayed up late, like every single night.
Thanks.
So, yeah, no, it was an incredible experience. That video was made by Neri's group, the Mediated Matter group, and they're really good at video. They know what they're doing at the Media Lab. So it was great to be part of Neri's group for that phase of this project. So anyway, I'll move on here. Just as long as we're talking about MIT and the other sort of influences that I've been able to be part of and give something to and get something from, there's a wonderful guy named Seth Riskin who runs a program called the Museum Studio at MIT. Not too many people know about it, but he is a real resource. He's very interested in the optics of light. I think he's taught at RISD sometimes, and he and I did a couple of collaborations, including this one, which was an exhibit about black holes. A speaker named Rainier Weiss, who had made an important discovery proving the existence of black holes beyond the shadow of a doubt. And this kind of phenomenon called spaghettification, which is a real word that talks about spaghettification is what happens, the behavior of matter near a black hole. So you get extruded and eventually gets spaghettified near the edge. So I made this device with Seth where I blew a reticello, using the reticello technique, this cone shape, which we illuminated from behind through a lens and through a lens, a grid, and onto a sandblasted glass surface. And then it was able to rotate very slowly. So it's very much a Rube Goldberg thing, but got me much more interested in using projected light. I just love when things get enlarged this much and distorted this much. It becomes all about the light, and the blown object is really not the primary thing, it's the secondary thing. So that was another jump for me, is to think about glass as a light device where the actual object is not what's important. What's important is the light, what's happening with the light. So then I started making these things in my own studio with blown glass balls blown into a Ballatini mold. I think that's what it's called, or a Ballatone mold, the bubble mold, but without any gathering over it. And then adding color to the sides and sandblasting. And I tried a bunch of different things, and I liked this idea of an eclipse. So two sides of this globe are somewhat opacified so that you get this penumbra-like effect of the sun partially shining through, and like you get with during eclipses. Essentially the piece is really based, and we did happen to have a solar eclipse around that time. So this is what the front of it looks like. And then I've got so it turns on a 1 minute, 1 RPM motor. So you're going to see a 1 minute video here. That is the entire period of this piece. So you saw it in full eclipse. And that's about 1/4 there. I should come up with a soundtrack for this. Now I'm all jealous about Neri's soundtrack. Right, and now it's back all the way around where it started again. So the thing that interested me about this piece is when I first made it, I could sit and look at it for a long time and not realize that it was a 1 minute period. It kind of continues to change, and it has so much detail and so many different lighting effects that your eye adjusts to in a darkened space, that at least for me, it's a really entrancing meditative experience to sit in front of this, which I did many times in my studio while making it. And I sort of hope that it has that effect on other people. So here, this is the last kind of section of the show. These are some recent pieces. I am this kind of almost closet glass blower, and always have a glass blowing practice going on at the same time as everything else is going on. So I've been making these Marini panels and interested in the idea of opacity and transparency in some of them. So they're panels and then some blown pieces. These panels have windows, and I will admit to being, Lino Tagliapietro was my teacher, and he's my friend, and he introduced me to this wide open wild west of Kane and Marini, and yeah, it's a huge it's just a huge language, and especially for a painter or an ex-painter, I don't know, I'm not an ex-painter, but it's an irresistible palette of things to play with. So I keep going back to Kane and Marini and trying things in an extracurricular kind of way. So these are fairly recent pieces of these panels. And then these are much more recent. These are the last 3 or 4 months been working on again, this idea of transparent windows among opaque areas. So the pieces are kind of perforated with places to look through. And I really dig this magnification thing that happens with the more clear, I think what the Italian or the Venetians call occhi marini, the eye marini, is a little lens. And I love that lens in the field of a much more opaque patterning. So a couple of these have these centers of transparent windows surrounded by an opaque field. I think these are probably part of the digital gallery, or maybe they are the digital gallery that Mary mentioned.
That's correct.
And yeah, these are all about in the neighborhood of a foot, you know, somewhere between 11 and 14, 11, 12, 13 inches. And then you can see the scale, 8 or 9 or 10 or 11 inches wide, depending on how fat they got. And I think that's it. That's it. So I'm open to answer any questions or take any comments or whatever.
Well, Peter, we do have a question. First of all, I just love how your love of light translates into so many different types of work, including the blown work, but also the printed work and the installations. You know, it just shows how one concept can be imbued into so many parts of life and creative life. We have a question. Could you discuss your collaboration with Rick Allen?
Oh, well, so Rick, I've met Rick a few different times. He and Shelley were teaching a class at Pilchuck when Marty and Eric Demain and I taught out there. Marty and Eric and I taught 2 classes, one in using computer-generated Kane ideas, using some software that Eric and a team developed to generate new ideas for Kane, and then folding glass. It was a very experimental class, and
You saw the folding glass.
I think it was the folding glass where Rick and Shelley were also teaching, and we just loved playing around with them. We did some things in an informal way in the shop. Rick gaffed some things with us, and we pulled a couple other people into these experiments too. And then they came out also for a conference. The time that the gas conference was supposed to be in Boston, and then it fell apart. We had a mini conference anyway, and I if my memory serves correctly, Rick and Shelley came out for that, and we did some work together, a demo with like a big Pegasus horse with like folded wings, and Shelley sculpted it and Rick put some things on it, and it was really fun. But I wouldn't say we collaborated to make, you know, work for a show or anything. We've really just had some play dates is kind of what it amounted to, but I love them and they're wonderful to work with.
Steve has asked, has this process been commercialized? I assume he means the glass printing process.
Yeah, I certainly haven't managed to commercialize my own career, that's for sure. But yeah, no, I think it has and it hasn't. So yeah, so they did. So the founders of this, Mike Stern and Daniel Lizardo and Chikara Inamura, the 3 students at MIT who came up with this idea and then worked with me in the glass lab to make it happen. They did found a company called Lios, L-I-O-S, that's got a web presence. And their idea was that they would try to design and sell high-end lighting. and or architectural features of different kinds. And they've gotten a few commissions, but it's been tough because, you know, until you're really established to get the kind of flow that you need to keep a business going and keep people employed who are spending all of their time doing this is challenging. So I'm not sure the company is going to continue to exist, but the printer's still out there. We can still use it. So I think it's going to be used on a project by project basis. Yeah, that's a good question, and it's an open question. I don't know ultimately what's going to happen with this technology. We can have a long talk about this, but there are various. It's an expensive thing to do. To run a printer like this, you have to be near a huge furnace so that you can ladle glass out of the furnace into the thing. You're using a lot of electricity, a lot of annealer space, a lot of cold working when these things are done generally. So you have to have some project that can support that kind of financial outlay.
And Stacy asks, have you considered using reclaimed glass in the 3D printer?
We have, and I think that is something we'd like to try to do. You'd need a stable source of recycled glass that doesn't change all the time. And the reason for that is that you will all know this, I think, is that every glass has a specific melting temperature and a pretty specific annealing temperature. So we really dialed in on this soda lime glass that we were using. We used a couple different glasses, and so the printing temperature was very specific and the speeds at which we were printing were very specific. So to change that day by day would be difficult, but if you had a stable source of a recycled glass, absolutely. In fact, I think using factory glass would be better in a way because it's engineered to set up faster. So I think that you could probably print faster than we were able to print.
Larry, would you like to ask Peter your question? It's a wonderful question, and generates possibility for a lot of discussion.
So Peter, thank you for that. I was wondering if the MIT Glass Lab can you hear me okay?
Yeah, I can hear you.
I'm wondering if the MIT Glass Lab is planning anything specifically addressing technology and art for the International Year of Glass next year in 2022. It seems like a natural. I just wondered if there was anything in the work that we could help promote.
Not that I know of, but I'd like to know more about it. I think that Mike and Daniel, the guys who are running this company, I mean, they're both glass blowers too. I think they would be very interested in an opportunity like that.
Okay, we'll be in touch. Thanks.
Okay, sure.
I think that's a really wonderful question and has so many possibilities. Does anyone else have any questions? This has been absolutely wonderful, Peter. We're so honored to have you here, and a great presentation. Thank you for putting that together.
Oh, my pleasure. It really was. Thank you so much for facilitating it, and to Debbie too.
Sure.
Peter, can I ask you this is Howard Cohn. I'm just curious if you've done any research or talked to Vaclav Siegler, who does all that work with light as it goes through prisms and other geometrical objects that he likes to create.
What's the name?
Siegler, Sigler, Vaclav, Vaclav.
That's where I'll go right as soon as I'm done with this meeting. No, but I'm interested in other people working in that area. No, I'm not really aware of. I mean, there are some things over the years that made me kind of understand that I'm interested in this low-level light kind of environment. Have you ever heard of Christian Boltanski? Do you know his work? He's not a glass guy. He's a sculptor. I think he is from France, and he's Jewish, and he likes to make work that is about the Jewish experience through history, especially during World War II. And there was a show that I saw of his that changed my life for good called Lessons of Darkness. And all the galleries, the only light sources in the galleries were candles that were illuminating little wire sculptures and casting shadows on the wall, which moved a little bit because it was in New York City. And so the subways go by and everything's sort of jittering a little bit. And there was something about the economical use of just candlelight and just a little hand twisted wire sculpture that like completely got me, you know. So yeah, I'll look into this guy, but there are a few people out there. Yeah.
You might enjoy Rubicek as well, another Czech artist.
And
I've got a book of his work, but you might enjoy him too. And he uses a mix of blown glass and float glass together, especially in his early work. So some of the Czech artists, I'll email you some names.
Okay, yeah, you have my email. Great, thank you, Vanessa.
I have heard of Christian Boltanski, and he has work in the Seattle Art Museum. So you might talk to them if you want to know a little more about Christian.
I'd love to see what he has. Have you seen the piece?
Yeah, it's called Walking Man. I think it's out in front. But they're kind of invested in him early on. So I think you might want to talk to the curator up there, find out more about him. I'm not the expert on that.
Yeah, I don't even know if he's alive anymore.
Neither do I.
Yeah, but because I saw this show in New York at the New Museum about pretty close to 40 years ago now.
Okay. Well, Boltanski came out of the Holocaust, and his work is very grounded there.
Yes, it is. It is. Well, I wish you had seen this show because it was a life changer. It was great. It made me understand that you can express a lot with just a little bit of light.
Wow. Yeah.
Any other questions?
Well, thank you everyone for joining us, and we look forward to seeing you next week. Oh, I'm sorry. Krana, David?
Oh, yes. I just want to thank Peter and Mary and everybody for tuning into this. We've known Peter for many years.
Hello, Rosens.
To the Glass Lab at MIT from, well, maybe 30 years ago, 25 years ago to, unfortunately, not during the pandemic, but listening to lectures that he's brought and the evolution and artists. And it's been a sheer pleasure. And we so much appreciate this program and encourage people to look into the Glass Lab at MIT. Of course, we have an MIT graduate next to me also. Anyway,
yes, that's
thank
right.
you
I remember.
so much, Peter.
Peter was great.
Oh, you're
Thank
so
you.
welcome.
Thanks so much.
Yeah.
Thank
and
you,
we'll let you
Mary.
know when we did not do a Hazel Grove lecture last year because
I know.
it just didn't seem worthwhile, but I think we're going to do something this year, and we'll let everybody know how that works out.
Great. And of course, we still love the pumpkins.
No, yeah, we're doing that. That's what funds the program.
Great.
That is an amazing. Thank you again.
All right. Well, thank you. I'm glad to see you.
Yeah.
Take it.
All right.
Thanks, everybody.
Thanks.
Okay.
Thank you so much.
So long. Thank you for attending, everyone.
Okay, bye-bye.
Bye.
Bye.